This is the demonstration of Science DMZ project that we are working on. The goal of Science DMZ is to provide a demilitarized zone environment for the Internet to traffic that is coming in ASU's data center. So we have devised this demonstration by incorporating different detection agents which are part of our Science DMZ framework. So we have a OpenStack based backend system that allows us to create two different tenant environments. So as you can see that I have this tenant one with assigned device ID, which is provided by our OpenStack based backend. So we can go to our OpenStack backend and check what kind of train test environment we have. So you'll notice that there are certain number of nodes that are connected to each tenant that we have created in the OpenStack backend. So some of these nodes you might notice are in red colors. So these are the nodes which have open ports like this one has port 22 open, which is a SSH service enabled. Similarly, some other VMs have some vulnerabilities that we deliberately put on these virtual machines. For instance, there is a highly severe vulnerability on open port 139, which allows a remote user to take advantage of this flaw and do some sort of privilege escalation. So our threat model is that attacker from outside or inside can try to exploit this vulnerability and use the privilege escalation on this machine to have a jump point to say this other virtual machine which is on a different network. So we collect all this topology information that you can see, and or machines have been created in the OpenStack based cloud backend. So using the CVE IDs of the vulnerabilities that we have identified, we analyze like what sort of vulnerabilities are present on each tenant. So for instance, we can click on each machine and it will tell us the number of critical, high, medium, and low vulnerabilities and the total vulnerability count on this virtual machine. So we use all this information to create attack analysis. So if we go back to our dashboard, we have a log of the intrusion events that have happened over past 24 hours, last 7 days, and last 30 to 30 days. So you will notice that some of these events have high severity. So we use our intrusion detection system at the gateway of the network to see not only the vulnerabilities that are part of our network, but any active intrusion events that are happening in our network. So we you can see that in last 30 days there have been 53 high risk intrusion events. So we combine all this data, and as you can see that in last 30 days we have had some intrusion events. So we use a snort based intrusion detection system to analyze all this data. and we construct what is known as a network based attack graph. So each node you can see on the end of this network specifies the vulnerability that exists in the network or the access control that is part in the network. For instance, this VM 192.168.10.4 can connect to this other VM 192.168.10.6 on this UDP port. So what happens is that a group of these access control list vulnerabilities are combined as preconditions to identify like what sort of privilege a remote attacker can gain by using the current preconditions like the access control list, the vulnerability that is present on the network, any active intrusion events. For instance, here the attacker can gain a network access on this particular virtual machine, and eventually he can use this virtual machine's privilege escalation on or network access to execute some code with some elevated privileges, and eventually the goal of attacker is to target some high value machines. For instance, he gained privilege escalation on 192.168.10.6, and then he executed code on 192.168.10.5. So this attack graph gives us idea of the transitive or the stepping stone attack scenarios that are part of our network. So what we want to do is we want to deploy some countermeasures using our SDN environment to limit the risk on these high value targets that we have in the network. But we want to do this in a more intelligent fashion. So, for instance, if I want to add a rule with a provided priority to block traffic from 192.168.10.5 to 192.168.10.6, and I am leaving this empty. So what I want to do is I want to deny this sort of traffic. So this request would be sent to our Open Daylight controller, which we can see here. So you can see that this is the corresponding topology in the Open Daylight controller. Additionally, what we have is that our intrusion detection system is simultaneously running a honeypot, which redirects the malicious connection attempts to these honeypot VMs, where we can do some sort of user behavior analysis. Like once the attacker has gained access into the system, what sort of damaging events or what sort of data exfiltration the attacker is trying to carry out in the system. So the difficult part here is that any sort of rules that we would insert to deny this sort of traffic, we want to also see what kind of security policy conflicts that can happen. So Webhub will be explaining the part where we want to identify these security policy conflicts, and Sukwa will be discussing what sort of honeypot logging we do as part of our Science DMG system.